I'm really glad that Martin has brought me up here today, and he's already said everything I wanted to say for my introduction. I'm Sheng. I've worked with Python for about closer to 8 years, 7, 8 years, and I was not trained in computer science. I was an accountant. I did audit, and then I learned programming. I fell in love with Python, and then now here I am. Okay, today we're talking about Pandas, which is a new library to do with DataFrames and how it is the new Pandas. Okay, does anyone here not know what is a library? It's okay if you can just just raise your hand. Okay, because we're trying to be inclusive. Especially I like to cater to newcomers. So newcomers is where the potential is at. So if anyone here considers yourself a newer developer, raise your hands. Okay, one. Okay, I need some of you newer developers to ask. I need to ask some of you questions later on also. Okay, you want? Okay, Ken, great. Okay, I will take note of these people. So, what before we talk about polars or pandas and all these bears, different types of bears, first we need to talk about data frames. Yeah, data frames are just tables of data. You'll see this word very often with capital D and capital F. And they're just tables of data, exactly how you work with in Excel. If you were a new programmer in Python and you didn't know anything about ecosystem, didn't know anything about Python, but you have ever been in an office, you have worked a lot with Excel, I'm sure. And then if you're trying to automate stuff in Excel, and you've just learned Python, you probably, your first instinct is to like search for like libraries to interface with Excel. But generally, that's not really what you want to do. What you want to do is to use something like Pandas to load your Excel data into a data frame and then work with the data from there. Okay, and yeah, and I actually learned this hard way because I went through that firsthand. Okay, let's first talk about the de facto standard library, Pandas. There's other libraries to work with data, tabular data, like Spark, but these are more for bigger data when you're working with multiple machines. For a single machine, Pandas is the de facto standard. Okay? It was initially released in 2008. That's 16 years. That's a long time already. 2008. So it's had its experience is mature, but it also carries its baggage, which means it needs to continue to support compatibility from before, and it's a pain when whenever you want to migrate. And it is basically the way to work with data frames in Python. And of course, I'm sure a lot of you know, and I guess a lot of you may not know if you're newer programmers, that one of Python's strongest domains in programming is to do with data. Data work, as I like to call it, data analysis, data science, machine learning. And Pandas really is a key part of this ecosystem, this data analysis and machine learning ecosystem in Python. If you go on to like Kaggle, Kaggle is a website where you do data-related competitions and learning and sharing. You'll see immediately the first thing when you go into a Kaggle course, how do you use Pandas to work with data frames? First lesson 1. Yep. So that's Pandas. This is what we are starting with. And now I'm going to tell you why it's not very good. Pandas is not pythonic. Okay, actually talking about pythonic, pythonic is a fancy word, but I gave a talk about a few years ago as well. I talk about how code can be pythonic and not pythonic, but I didn't really talk about how libraries can be pythonic or not pythonic. And I guess in a simple sense, a library is not really pythonic if the way that you're recommended to write code and the way that you typically write code with that library is not really pythonic code. Yeah, so we'll see much more clearer examples of this in the next slide. But overall, I want you to kind of remember this. Pythonic code or a Pythonic library should have consistent syntax. Syntax is for newer programmers is just the how the different keywords in the library for you to interface with the library, to use the different the library, the functions and the methods and the classes, yeah, that you have. The syntax should be consistent, and definitely the syntax should use intuitive names. One intuitive name that I really like, right, is from one of my favorite libraries, which is called Random. Does anyone know what Random is from? Random is from the standard library. So random is from the standard library we use to generate random numbers, and there's a very nice function inside there called random.choice, and basically it just makes a random choice from a list of items that you pass into it. It just returns you a random choice. So which is like really, really intuitive. This is what I mean by an intuitive name. Yeah, so these intuitive names are really important for syntax because it lets developers learn the syntax more easily and naturally and quickly. As you will come to see, and as many programmers have experienced for themselves, Pandas code is often all over the place and unintuitive, and the syntax is unintuitive. We'll see examples of this. And this is one key code I think I like about pythonic code, which is there should only be one obvious way to do something. And we'll see how Polars is much better at this than Pandas. Okay. Pandas is ugly. Okay, I remember there's a few people here that are considering themselves newer programmers. Okay, Pandas is ugly. When you want to read data into a data frame, remember a data frame is just a table of data. Just keep in mind your Excel table of data. If you want to read data into a data frame from a CSV file, the comma separated values file, it's like an Excel file but simpler. You use pd.readcsv, and pd, for those who of course haven't used Pandas, is you normally import Pandas as pd. So that's the standard convention for Pandas. Pandas pd.readcsv. So when you want to write the data back to your machine, what would you expect this to be called? So first we say is df dot something. So df stands for data frame, right? Generally you load it into a data frame. So df, you do a pandas.readcsv, load it into a variable called df. And then now df, we're going to write it back into a CSV file. Good sir, what is your name? Oliver. You said you were a newer programmer. What would you expect? Writing data from a data frame, what would the method be called? Here it starts with data frame already. So we know it starts with data frame, so it's a method. Not sure. How about the lady at the back? You're a newer programmer. No, this is exactly, you're not supposed to know. You're supposed to, if you were to design Pandas from the ground up, what would you call this method? You're going to, reading data, read CSV. Writing data, df dot, write CSV, right? Right, CSV, exactly. Actual code is to underscore CSV. There is no consistency whatsoever. If you wanted to write to CSV, why not start with from CSV when you're reading data? If you're doing read CSV, of course you do write CSV, right? So it doesn't make sense. Of course, all these examples are pulled from, yes.
Although I think there are a few ways to achieve it better.
Yes.
Because if you're saying from CSV, right, maybe it's even more clearer if it's data frame dot from CSV.
Yes, that could even be better, yeah. Then both would be methods, right?
Because the logic from using from and to is that you're converting from CSV into the data frame.
Indeed, yeah. So I at least
in this case, it rewriting. What it means, one is reading data, the other one is converting data.
Yes, we can think about it that way, but to be
But it's
yeah.
more consistent for them to have more common sort of like
Yeah, a consistent API, a consistent syntax. Yeah, there's many ways to think about it, and as you are a more experienced developer with Pandas, it is like you get used to your best friend's quirks, and you can oversee all of their little problems and hiccups. But when someone is new to them, they will these little things are really these little frictions are amplified when for a new programmer. Yeah. So for me, I would have called it write CSV. Okay. But of course, it's also subjective. Next one, next example. Filtering a data frame. Okay. For those, right, who are new programmers, right, you just learn Python. Now you're going to learn, and you learn Python because you want to learn data work. You want to get into a data science job, get that very high pay that is in the newspapers. Then you learn Pandas, and suddenly everything is not really familiar. You see this square bracket syntax, and usually that is for accessing like some kind of a list or iterable or a dictionary or something. But suddenly you see this new thing. It's for the data frame. So you have no idea how to use it. You have no idea what it's supposed to mean. And inside there, there is like what looks like a condition. So like what is going on? This is really basic stuff. But even here, I think there's already a lot of problems which are surfacing. And of course, all these examples are adapted directly from the Pandas cookbook, which is Pandas official documentation. Next, let's get even wackier. Very standard stuff, stock standard stuff that you want to do, setting a column value. Okay, we have two columns in our data frame, our table of data, column A and column B. We want to set column A value to be -1 when column B is 5 or more. Suddenly we are seeing .loc, which by itself makes no sense whatsoever. It's not an English word. Is it an English word, Martin? Location, yeah, it could be locate. Why am I talking about location now? It doesn't, to me, it didn't make sense. And to a lot of people, it doesn't make sense. And usually after a object with a dot something, you expect this something to be a method, correct? And after a method, you have parentheses. No, .loc, we have square brackets. Why are there square brackets? This doesn't make sense at all for a new program. It's not Pythonic and it's ugly. And suddenly we have two positional arguments. First one, if you know that it's the condition, fantastic. If you're not, too bad for you. First one, we could use the dot notation, df dot column B. Second one, we cannot. We need to use a string here. It's ugly. And it gets worse. Now, look at this. We're setting a column value conditionally. Only difference now, we're adding an else. So if it's something, we do -1. If it's not, we do 1. And suddenly, we need to add in a new library, np, which is numpy. Import numpy as np. It's often imported with Pandas, and this is one of those habits which everyone has done. Everyone just copies from some documentation online, and you just copy and paste it. You just change wherever it makes sense. But if you look at the syntax, this is really bad. This is really bad. Like, what are these? What are these? It's bad. It's bad. Okay, it's bad.
I didn't get the first two.
Yeah.
But I'm thinking this could have probably been a ternary or if else.
Yeah. Something. Yes. Which let's keep what you said in mind. Is ternary or if else, and we'll see what Polas does later. Foreshadowing. Okay, and of course, when I think that Pandas is ugly, of course I have to go online and seek validation for what other people also think. And of course, a lot of other people also think that it is ugly, inconsistent, no pattern whatsoever. Coding in it is hard. It's a Franken monster. And that's where I heard about Polars. Actually, I heard about this from my boss, who was also quite tech, my current boss, not my ex-boss, but from my current boss, who also is quite tech forward. And he told me about this data frame library. And he said it's pretty cool, and it's catching up in popularity. And this is one of my favorite tools for actually evaluating technologies. And I think that this is the guy who taught me how to use this. Is that right?
Use what?
Star history.
No.
GitHub star history.
Oh.
Yes, right. Maybe. Yeah, maybe. But this is one of my favorite tools. It's not perfect, but it is a great tool. You just go to star-history.com, and basically, when you go to GitHub, which is where all open source code lives, and the Polars code lives there, Pandas code lives there, pretty much every piece of open source code lives there. You look for the repository, and then you paste it into the website. On GitHub itself, for every repo, you can actually press a star button, which means you really like this repository, or it means whatever you want it to mean. But generally, people, I have found it a reasonable first indicator of how good of an idea it is to start learning a library. Because in programming, right, in the world of programming, basically, can I say cloud? Cloud is everything. It is the monopolies which grow the fastest. When the library is the biggest, it gets the most support, it gets the most users, which continues to further its documentation, further its resources, further other supporting libraries for it. And that's why you want to stick with, you often want to stick with what is the biggest library or what is the next biggest library, the next to be biggest library. And on the y-axis there, you can see the number of stars. And on the x-axis here, horizontal axis, we can see the dates. Back from 2010, 2008, you can see Pandas has a very steady rise in stars. And you can see the nice slope up here. And of course, you can see the red slope here is Polars. Can anyone tell me something? This go back to math class, right, in primary school. Anyone tell me something about the red line compared to the blue line? Anyone? Blue line, red line, blue line.
I didn't really get it from this. Just I go like onto people talking about Rust, then someone show about the project. One of the project is this one.
Yes, this is very popular. Yes.
So you got a lot of like the enthusiasts got into that.
Indeed. Yeah, a lot of enthusiasts got into that. But anyone can tell me about the line, just between the lines themselves. Red line is steeper. Yes. Sorry? Higher rate of growth. Yes, higher rate of growth. Yes. And it's because much more obvious when we put the lines together. Right? You can see that it is higher rate of growth and means that people really like Polars. And it has to be a reason why. Why do people like Polars? Let's look at why. Polars is not ugly. That's the first thing. Read data, pl.read CSV. PL is called is import Polars as PL. And write data, df.write CSV. It's the perfect opposite, and it's perfect read and write. Next. Polars is definitely not ugly. If you want to filter a data frame, what do? You take your data frame, df, and you do a method on it, .filter. That's beautiful. That's beautiful. And then of course inside, what would you expect is the condition, right? Because you know you're filtering. So what will you need to filter? You need a condition. You put a condition inside there, which is your column A less than 5, less than or equal to 5. Next, setting a column value conditionally. Okay, so now if you want to have set a column value, you always use this with columns, or there's one more API which is select. But generally, you just use with columns, and then you just use a keyword argument column A. So that's the column name, which is column A. And what do you want the value to be? When this condition, then -1. Isn't that like beautiful? Isn't that beautiful? I know my room is very messy and my workspace is messy, but I don't like my code to be messy. So this to me, when I look at this, I feel a sense of joy inside. It's beautiful. When this, then this. It makes perfect sense. If you remember what we saw previously, it's hideous compared to this. Let's go next. Yeah, let's go next with an else. Remember what our good friend said? What if you have a ternary operator? When? Then we do this. Yeah, true. It's a chained method, but it is like similar, like if then else, right? And it's so simple and it's so like intuitive, isn't it? Like just beautiful. Yeah, the chain methods. Yeah, it's a common pattern, and I think it works really well here. Yeah. So let's continue. Okay. Okay. Okay, now let's talk a little bit about some Pandas basic API. I think some of you also want to learn some basic API. There are three main, in the documentation, they call it contexts, or I would say the three biggest things that you want to do when you're working with DataFrames. First thing is selecting. Second, selecting different columns and selecting different values to put in columns. Second thing you want to do is filter by the different rows. So you don't want all the rows, you only want a subset of the rows in your Excel table. Just think of an Excel table, you want to filter, right? Yeah. And then you have aggregation, which is like group by, which is like your pivot table. Yeah, or SQL group by. So that's the first three, and we'll talk about two more big things to do, how to do them later. So the first one is selection. We just do df.select and or df.with columns, and then the columns inside. Yeah. So and the columns with whatever transformations you have inside. And the difference between these two is pretty important, but it's pretty simple to grok as well. Grok just means to understand intuitively. To select means the resultant value is only what you put inside the columns here. So I just want to select these columns. But df.with columns means I want to add on these columns onto my data frame df. Or if I already have these columns in my data frame, just overwrite those values. That's really intuitive, right? Yeah, and yeah. So that's the difference between select and with columns. Second one is filtering. Filtering, we just do df.filter. Really intuitive again, simple. And whatever condition you have is inside df.filter. Aggregation, you have df.groupby. Groupby is the exact same term that we use in SQL. Actually, who uses SQL here? About half or maybe 1/3. Yeah. So yeah, group by is exactly the same term you use in SQL. So it's basically like using a pivot table. Like let's say you have 100 rows and 50 of them are for apples and 50 are for oranges. You can just group by apples, apples or oranges, the fruits, and then you just have two columns, right? And then you can aggregate the other columns in whatever method you want, whether you want to get a mean or you want to get a average or sum or whatever. And two more most common operations, I think, is joins. Also extremely common, of course, in SQL, where you want to join one table of data with another. And in Excel, of course, you use VLOOKUP, right? Yes, VLOOKUP, right? And yeah, okay, VLOOKUP, yes. Indeed, yes. So of course we use VLOOKUP or whatever to combine data from two different tables, right? And so here you just use your first table, DF1, DataFrame 1 join with DataFrame 2, and how you want to do it. It can be left join, inner join, outer join, full join, or whatever. And you can also add in one keyword argument I really like here, which I use a lot in my work, is validation. So you can do a many-to-one validation to make sure that the join doesn't result in duplicates. Yeah, which actually happens a lot in the banks.
In the join example, is it automatically finding the columns with names in common? Is that how it's doing?
No, you need to put down. I'm so sorry. You need on. Yeah. So you need on whatever column names are in common, or left on, left underscore on, and right underscore on. It's the same as in this case. It's the same as in Pandas. Yeah. Right. Yes. Yeah. So I really like the many-to-one validation to avoid getting duplicates from my joins. And last one is concatenation, which is also extremely common. We have two tables and you want to join all the rows together. You want to add the rows from both sides into one big, smoosh them into one big table. And you just do pl.concat 1 and 2. You have 1 and 2. Okay, another reason to use Pandas, actually this is the main thing that draws a lot of people to Pandas, is that it is silly fast. It is ridiculously fast. Of course, this text here, I don't expect you to read it. I'm going to tell you what it means. You can see there's basically, look at the green. There's like 7 columns of green. Each one is a query, like a standardized query they use for comparing the speed of different libraries, data frame libraries. And how tall it is how long the query took. So the dark green here is Pandas. So in almost every, let me see, 1, 2, 3. Oh, in almost every query that they compared, Pandas was the slowest, the tallest dark green bar, only except that one. And where is Pandas? Pandas is the dark blue one down here. So it's basically next to nothing compared to how long Pandas is taking. Just for get a sense of the numbers here, Pandas took 32 seconds, and this is about 1 to 2 seconds for Pandas. Why is Pandas so fast? I don't really want to go into the background of this, but there's 3 main reasons. First is that it's written in Rust, and Rust is a much lower level language. It's a very popular language as well. And compared to Pandas, which was written on top of Python libraries. So slow on top of slow gets slow as well. It also has parallel execution. When you're doing adding with columns, all your different columns transformation, every column you're populating with data, it does them all at the same time. And it's able to do that because it's written in Rust, which allows concurrency very easily and safely. And the last thing is lazy execution. So lazy execution is a little bit tricky. Basically, it is where if you're a lazy person, you don't want to do things until the last minute. And if you're a lazy script, you don't want to do your execution until the end of the script, until the last minute that you have to. And so in Pandas, it's the same thing. All your functions and methods are looked at, but they are not executed until the last moment that it has to be executed. So what this does is that it allows the library to look at all the different operations that the data has gone through and optimize everything in the right sequence and only processing the data that needs to be processed. So it basically does really smart query optimization for all your queries and all your transformations in one shot at the end, instead of doing piecemeal. But you can also do the usual eager execution for things like data analysis. where you want to immediately look at the data for like EDA in your data analyst work, yeah, you can still use that.
When you're calling resources, because usually like when you call resources, it's like enthusiastic means you call them guessing immediately.
Yep.
Then lazy is like you will try to defer or wait.
Yeah, exactly. In many other contexts, it is like that. And here as well, it wants to wait for the execution of the data frame manipulations until the last minute, so that it can
display it, right?
Yeah, when you want to display or when you want to output it, you want to write it to a file, or the last minute that it has to.
It's sort of like the concept more familiar you're thinking of a web page. So like usually like you will load the whole resource, everything images. So if you lazy load the images, that means you only get to see when you scroll down to the image.
Exactly. You only get it when you need it. Yeah, that's right. So in general, programmers are always looking for lazier ways to do things. And this is a good example of it, and done in a good way. At my job, I've done a lot of Pandas scripts. I work at DBS, and I know we have some outages recently, but we are still not too bad. I'm in the tax department, near the tax side, so we calculate tax for billions and billions of revenue. And so I have to pull data from many database tables, and then join the data for lots of different information from different tables, and manipulate the data and either write it back to a database and usually generate some Excel report. So
Your database connectivity, do you use other libraries or
I just wanted to get to that. Yeah. So in the past, when I was using Pandas, we were using an ORM, which is the standard one, SQL Alchemy. Yeah. And Polars actually it supports SQL Alchemy as well. But in its documentation, it actually mentions that SQL Alchemy actually slows down the code. It can make your loading of the data slower. Yeah. So it has another API to pull data from databases. Yes. You mean SQL statements? Yeah. So normally, so there's normal two ways of pulling data from databases with Python. One is you can write raw SQL, or you can use an ORM like SQL Alchemy, which turns your raw SQL into like object-oriented way of working, object-oriented way of working. So which a lot of people prefer. Yeah, but if you use the Polars method, you basically need to pass in raw SQL, but it's faster. So yeah, I'm using it. But I'll talk about it later as well. I have another slide on that. Yeah, so these are the main things that I do. So bearing in mind these things, this is my experience with Polars. 2 plus, 3 minus, not equally weighted. I really love the API. I can intuit the code much more easily, and it's easier to learn, easier to search, easier to learn. And when I look at the documentation is also very beautiful. They have very good recommendations and fixed recommendations of what to do in each scenario. So yeah, that makes things really easy to learn, and it's consistent. Yeah. So I think that makes it especially good, right, for newer programmers, especially people who are new to Pandas. Because if you are new to Pandas, it's going to take a long time to get used to the quirks and the rough spots of Pandas. Whereas you are likely to have a much more smoother experience learning Polars. And of course, I have definitely noticed much improved performance in my code as well. And some of the negatives I see, so one of the good, of course, when it's much faster, I get to go home earlier, so I'm really happy about point number 2. Resources are not as plentiful. Of course, this comes with being a newer library. There's just not that many resources. If you want to look for how to do something, the most common thing you actually do is Google it, and you look at the first Stack Overflow question and answer, and there's fewer question answers for polars because it's just newer. But the documentation is really good, and this problem is becoming less and less of a problem with every passing month. Less support as well. So one of the examples I can really give here, which I experienced myself, is actually what you were talking about, loading data from a database. Because remember, I'm pulling data from 20 different tables and many different endpoints. But sometimes from one endpoint, I want to make one connection and pull from like 15 different tables from that one endpoint. But the faster Polars API doesn't allow me to reuse that one connection. I need to make a new connection every time. So that's slower, but when I add it all up, it's still faster than my old code. So yeah, but and also I did find I was looking for other ways to reuse the connection, but I had used a third-party library, and some third-party libraries only support certain types of databases, and my database wasn't one of them. Yeah, and the lazy API is not always trivial to implement. Just now I talked about the lazy execution, which contributes to the fast speed of Polars. Polars is still plenty fast without the lazy execution, but this really makes it faster. The lazy API is what you need to make Polars do the lazy execution. It's quite simple in general. It's just in general, when you first load your data frame, you call df.lazy, and then until the next point where it can no longer be lazy, then you convert it back to a proper data frame. Yeah, and then when you can lazy again, you go back to lazy, then you go back to proper. So that's basically how you do it, and it's not that trivial to implement, which was not a great surprise for me. But yeah, it was not trivial to implement, because when I tried to implement this and I had to join like 20 different tables together, it just gave me a lot of different errors. Yeah, so that was not a great experience. But even without the lazy API, so in the end, my production scripts are not using lazy API, but it's still much faster than my old Pandas scripts. So I'm still really happy. Just some gotchas. Gotchas are basically those things where it really surprises you when you first learn to use this library. Group by doesn't maintain the order by default. You can think of Polars as a really messy worker. It's really fast, but it's kind of messy. So it doesn't leave things tidy. If your apples and oranges, you have 100 rows, apples will be before the oranges. After group by, your oranges may be before the apples. But you can, of course, set a keyword argument to maintain the order, which makes it slower, of course. Yeah, which is why they don't maintain order by default, so it can be as fast as possible. df.unique, where you want to keep only unique rows, remove all the duplicates. It takes any of the rows by default. Instead of where sometimes you might expect it to take the first row that it finds and ignore the other duplicates, but no, actually it takes any of the duplicate rows by default. Yeah, of course, you can put a keyword argument to avoid this problem. Yeah.
Usually it's because things like sorting and searching, it doesn't like do it sequentially or in order.
I think this happens in Pandas as well, is it? I'm not very sure actually. I think it happens, right? Yeah.
It's because it's faster to just take whichever.
Yeah, it takes whatever comes first. Yeah.
So maybe when you're doing sorting or searching, you should maybe do it at the end.
Yeah. Okay. And last is my last slide basically. In conclusion, if you came here today, you're probably interested in Polars, and I think if you have a new project where performance matters, or you have lots of first-time developers on the project who really don't have much experience with either Polars or Pandas, why not just try out Polars? Yeah, they might be taking up Polars faster than they learn Pandas, and you get to save a lot on performance as well. If you really need things to work 100%, maybe you can try some prototyping in Polars first, or just stick with Pandas for now. But make sure to keep your eye on Polars because it is really growing really, really fast. Month by month, it is developing really, really fast. It is so fast that just at the start of this month, it just released its 1.0. Yeah, 1.0 version. That's it.